Now when we come to comparison tests, we have different types of formats. The first format can be this one where we have this for all x greater or equal to a, right? Then the second one we can have a less than b less than or equal to not less than b less than a. And this, all this, you see, right? So we can have these types of integrals. So the first one, let's look at the one where we have for all x greater than a. In other words, we are given a and also infinity. So we'll look at the example. So we'll say that if this is the case, f of x is less than g of x. So remember this type of questions, right? This one's where they say 2 to the n plus 3 to the n to the 1 over n. The limit of this will be equal to 3. We're using this type of comparison test. Because when you have them, you first take the smaller one, you bind it or you bound it above. Can hear you? But you say this is less than or equal to, you take the bigger one, you put it here. Then you would add both sides, you find yourself a is 0 plus 3 to the n less than or equal to 2.
So we can't hear you.
Can you hear me?
Yes. It's like you're underwater.
Now you can hear me?
Yes.
Alright, it's fine. Plus 3 to the n less than or equal to 3 to the n plus 3 to the n. And then you see, this comparison test, we took it from here, of applying on this question. So, what I'm saying here, let me cancel this, is that this tells us that if we find the limit here, right, that limit might also apply on this limit, because this will say that it's less or greater than, right? So here when we come, we're going to say, if we're given this condition, or we're going to be given f of x, then we reduce that f of x is in comparison test, right? When we reduce it, we might take that integral or that function that we reduced, we find the integral, we apply the integral, right? If we find that that limit converges, we are saying that also this one will converge. You see, right? So that is comparison test, and there's a difference between comparison test and limit comparison test. So here we're saying that if the integral of g of x converges, then the integral of f of x also converges. So that's how we're going to deduce or conclude. Vice versa, if the integral of g of x diverges, then also the integral of f of x will diverge. Right? That's why I just wrote vice versa. So if we come to the limit comparison test, we suppose that f of x is greater than what? 0. It will always be greater than 0, right? And g of x is greater than 0. So you're only going to apply this comparison test if this will always be greater than 0. So it should be increasing, because I'm sure for decreasing, there's this other question that when we apply a comparison test, it becomes a problem, right? So I didn't realize it. I think someone today brought it and I looked at it and realized that the question was decreasing, and I was not supposed to apply a comparison test if the question is decreasing. So it's very important to check whether that function is increasing or decreasing before you apply a comparison test. And g of x greater than 0, right? Then we say that for all x, you see I even highlighted it with green. For all x greater or equal to a, and that both f and g are integrable. You see, right? On every interval ab, obviously a, b, given that a is a positive one minus b, you see. And then where b is greater than a, obviously the upper limit should always be greater than the lower limit. And then suppose further that the limit, here we're talking about this, right? The limit, it's a limit comparison test. Let's say first I'm given this 1 over x plus 1. This is our f of x. If I say that this is less than or equals to 1 over x, now this is my g of x. This is my f of x. So what I'm saying here is that I must take this over this. I find the limit. You see, and the limit should exist. That's why I'm saying that it should be greater than 0 or less than infinity. It shouldn't be infinity, it shouldn't be 0. Then the improper integral f of x and g of x either both converge or both diverge. One can converge and one diverge. If one diverge, the other should also diverge. You see, right? Then for this example, let me erase. Then from there we're given these exercises. We're given number 1. We have the integral from 1 to infinity of it's what? It's dx. It's dx over what? Dx over 1 plus. Okay, let me go and write it. Dx 1 plus x to the 4, right? 1 plus x to the 4. 1 plus x to the 4. And it was from what? It was from what? Yeah, so now we're given this, right? Then we should determine whether it converges or diverges, right? So we're saying that we're gonna use the limit comparison test. We agree, right? So what we can do, we're given, we can say that let f of x be equals to 1 over 1 plus x to the 4, right? And we say g of x be equals to 1 over x to the 4. So that
I can't hear you.
sorry, such that, can you hear me now? Let me turn this thing. Let me just try to turn, because I think if I put it down, I close the mic. Let me just try to turn it. Okay, can you hear me now?
Yeah.
Alright, such that f of x, this is 0, less than or equals to f of x, less than, so g of x. We agree on this right now. And check this, and for all x greater or equals to 0. So let's go back and check. It was greater or equals to 0, right? So let's go back and check. If it's greater or equals to 0, not 0, it was a, yeah, a, not 0, a. Our a is what? Is 1, right? It's 1. This mic. That's 1. This is 1. That's 1. So now we have this, right? We were using "so will be happy if you use this condition." You'll know that, man, these people understand what they're doing. So we see what we're doing, right? We really understand. So if someone like you does this, don't know like, hey, this person understand what they're doing. So Or you can say, someone would say this. Let me just erase this. Someone would say f of x is greater or equal to 0 and g of x is greater than 0 and for all x greater or equal to 1. This one is always your A, you see, right? Then the reason I'm writing these conditions, I don't want you to cram comparison test. I want you to know when to use comparison test. When is it not? Sometimes you find a function like this, but it's not compatible with comparison test. You see, right? Then if you have this, you may have IE. You know that 1 plus x to the 4 is less or equals to 1 over x to the 4. We agree with this one, right? Now, this is the limit comparison test. Do you agree with me here? And then,
Yes.
from here, let me start with this pen, I think. So from here we can now check the limit. We say that the limit as x approaches infinity. So it's not always the case that we're going to apply it when it's approaching infinity. So here it's approaching infinity. Let's go and check. You'll see here it's approaching infinity. So we have this comparison limit. We're saying that x approaches infinity. You see, right? Then on, we're saying that x approaches infinity. Then on the other one, where we have this condition, x approaches a to the plus. You see, right? It should approach this value here. It should approach this value. Always on the second one, where you see that you have this case. In other words, that case is where you have limits, like this one, where both of them, either both of them give you undefined here, or they don't give you anything when you plug. You see, so if you plug 2 here, what do you get? Just that here we have limits. You see, these are limits. This is not infinite. So as long as they're limits, you should know that this one is the second part of, because we're saying this, we're gonna say that x is in between. X is greater than 1. We're saying that x is greater than 1 and it's less than or equals to 2. You see, right? So that's what we're saying here. And also this is the same case. X should be greater than 0, because x can be equals to 0. X can be equals to 1, because if it's equals to 1 here, we get undefined here, you see. So we're avoiding that mesh. That's why I'm saying this. X should be this case, because if it's equals to 1, this will be undefined. And this one also, x can be 0. So we're going to say 0, x is greater than 0 or less than or equals to 1. We come back to this one. X can be 0, and unfortunately x can be infinite. So here can be this one, infinite, but still we're going to compute using the limit of this one. You see, right? So yeah, when it comes to understanding these comparison tests, it's very important. So now let's compute the first one. We're finding the limit. The limit of f of x, over g of x, which would be equals to 1 over 1 plus x to the 4 all over 1 over x to the 4, which this will be equals to, if I change this, I'll get that this is x to the 4 over 1. No. I must use the limit. Why am I not writing the limit? Must use the limit.
the limit as x approaches infinity of 1 over 1 plus x to the 4 over x to the 4. This will be equals to the limit as approaches infinity of x to the 4 over 1 plus x to the 4. So if I factor out x to the 4, if I factor out x to the 4, right? If I factor out x to the 4, I'll get 1 over x to the 4 plus 1. And this would be 1 over 0 plus 1, which this would be what? 1. Do you agree with me there? Guys, do you agree with me?
Yes.
Yes, you see. So this is the limit comparison test. So what did the limit comparison test say about the limit? It says that it should be what? L should be greater than what? 0 and less than infinity. You agree, ne? So we found L and it satisfies this condition, right? So what can we say? Can we say it converges or diverges? Can we say it converges or diverges? What can we say?
Converges.
It converges. Anyone who says it converges, those who agree?
Yeah, it converges.
Also another one says it converges. Another one?
I said,
Yes.
if it was infinity, it would converge, right?
Infinity? No, infinity is not included. Infinity can never converge.
Diverge. Yes.
Yeah,
converge.
it would diverge.
Yeah, okay. Fine.
Yeah. And I think if it was also 0, because you see that 0 is not included, right?
Yes.
Yeah, it would diverge also. So, any question? I think I would scan these ones, but the limit comparison test, I don't know if they can give me the limit comparison test there. Any other question? So if it was 0 or infinity, it would diverge. 0 infinity. You must keep this in mind. These are free marks, guys. You just need to be open-minded when you're doing these questions to know what to do. If they give you certain question, don't rush to integrate a limit comparison test. This is the simplest. If you don't know integration, this would be where you're supposed to eat. I don't want to see anyone there integrating when it comes to limit comparison test. Yeah, on comparison test, you can do that. Right? On comparison test, the reason why I didn't touch comparison test is because you know how to reduce. If you were going to integrate this one, again, you see the integral of this one, you reduce it, you say this is less than this, then you integrate this. Already I showed you how to integrate. After integrating this, then you can say, I get it, this one, if it converges, then you can deduce that also this one does what? Converges, you see. So the one which is different is the limit comparison test. So that one, I must touch it. So we don't have questions, it means that we can move, right? Can we move?
Yes,
Yeah.
we can move.
Yeah, I don't want to make this one to be too long. So it means that we would say, and I was there. I forgot how Yose wants this to how he wants us to deduce, right? On this one. I forgot. Come in. I forgot how I want. I don't know what. Come in. Oh, these people are looking. So I forgot how they want us to deduce on this one, right? So you can just look at how they were teaching you on that class on how they wanted to deduce. But I know that the conclusion is no. We're not just gonna say this thing converges. It must be a little bit long saying something else. So the next question that we would have, it would be this one, which it would be a bit similar. So can I skip this two and then you'll do them yourself? You'll try this. It's the same thing. You're just gonna reduce there and there. This one you're just gonna reduce it to 1 over e to the x. Then you find the limit of this over this. And then this one also, you're just gonna reduce this. Then you find the limit of this over what you'll get. So it's a bit simple. So try this too. So that because of time, I want us to touch on these ones. So the limit comparison test. The limit comparison test. Okay, let me give someone something here. This one is go on. The limit comparison test. The limit comparison test will say, suppose that f of x is greater than 0. Everything else here is the same, right? And g of x is greater than 0. The only difference is this one. Remember that one was saying that x is greater or equal to a, right? Then this one says that x is in between a and b. So what we have here, we see that both g, and this one, check guys, these two, let's check if when we plug them, they're gonna give us infinity. So if I plug minus infinity here, what do I get? If I plug minus infinity, I'm going to get e infinity over 1. This will approach 0. You see that this one, if I plug this, it won't give me undefined. You just get there and you see minus infinity, you use that, I'll have to put 0 in between. So if I use this, it won't give me undefined, right? If I plug minus infinity. But if I plug infinity, that's when it can give me undefined. Let me check it. Okay, let me check between these ones. Let me not just deduce. Let me not just conclude. Let me just do. If I don't remember, I'm speaking the opposite here. Let's start with infinity, the top one. Usually, according to this one, it says that the top one should not give you undefined, right? So this would be 1 over infinity. This would approach 0, right? So this would be 1 over infinity. Yeah, this is fine. 1 over infinity. This one would give you undefined. And then you would have to say reduce that one. Then this one, if I plug 1 over 1 plus e minus infinity, this one would approach 0, would have 1 over 1. Yeah, it's correct what I was saying. So this one won't give you undefined. It's only the top one that will give you undefined. So now this one, we know that x is in between a and b, and a is always not included. B is the one that is included. So, and it says both f and g are integrable. And on every interval cb, where c is in between, that which is our x, a, b is like that. C is in between a and b, and they're both not included. Suppose further that the limit we take of a, you say that we take the limit of a, we say f of x over g of x will be equal to L. Then we know this is always the case, L should not be 0 or infinite. Then the integrals are either both converge or they both diverge. So let's look at the first one. Which one should I do here? You can do the first one, right? Now I'll do the first one, and then you'll try this. So this will be the last one, because I can't keep you for too long. So we have this. We have one. It's the integral of, it's what, from 1 to 2, 1 over, okay, 1 to 2. So from 1 to 2, it was from 1 to 2, 1 over root of, it was root of what, guys? Guys, it was root of what?
X squared minus 1.
X squared minus 1 dx, ne? Oh, so we have this now. So last time I let f of x be equals what? 1 over x squared minus 1. We agree, right now? Do you agree with me there? Do you agree with me, guys?
Yes.
Yes. And then now I can say and g of x to be equal to g of x will be equal to 1 over the root of x squared, such that f of x is greater or equal to 0 and g of x is greater than 0 with x being in between is greater than 1, less than or equal to 2. You agree? Because if I plug 1 here, I get undefined. If I plug 2 or any number between 1 and 2, I won't get undefined. We agree, right now? So this will be simple. So from here I can find the limit comparison test now. This pen turns off, I don't know why. We can have the limit as x approaches. Don't forget here we must approach a from the positive, right? Of f of x over g of x. You agree with me on this one, right? We must approach this. Is there anyone who agrees with me here? You agree, no?
Yes.
Alright. So which means that this one we're going to have the limit as x approaches 1 from the positive. F of x is 1 over root of x squared minus 1 over 1 over root of x squared. And then this would be equal to the limit as x approaches 1 from the positive. Then this would be x over the root of x squared minus 1. And this would be, if I factor out x on the denominator, I would have x. Let me just write everything, it's fine. But these are some things that in this level one was not supposed to even touch them. And then this would be, since we're approaching positive, the x will come back, would come out as positive. So this will be x over x 1 minus 1 over x squared. So, or even if I add Omar, that's fine, I have to get rid of that. And then let me see. The denominator would still give me, it would still give me that right now. It would still give me, let me see. Yeah, it would still give me, the denominator will still give me 0 right now. And I'm trying to get rid of that 0. It means that we must apply a different approach. What other approach can we apply here to get rid of this? Anyone who knows what type of approach can we apply? Oh, it's fine, let's do this ish. I think we can do this. There's this one which we can try to apply. X over root of x minus 1 x plus 1, and this will be equal to the limit let me see. Yeah, it's fine. It won't work like this. Let me just edit the limit. I can take it step by step. That's fine. For it means that I have to edit g of x. I'll say that g of x will be equals to 1 over 2x minus 1. So I can just reduce the x there, the x squared, and make it like this. That's fine, because if I take it like that, it won't work. 1 over the root of x squared minus 1 over x minus 1. So let's try this one. And this would cancel this. We'll have the limit as x approaches 1 from positive of 1 over the root of x plus 1, and this would be 1 over 1 plus 1 over 2, no, 1 over root of 2. So you know this limit is greater than 0 and it's less than infinity. We agree, right now?
Yes.
Yes. Therefore, does this converge or diverge?
Converges.
Yeah?
Converges.
It converges, right? So we're going to say since, so I think that the reasoning was like this. Since the short one was this one, right? It's this one, right? So we're going to say since 1 over x minus 1 converges, then I'm going to say then by limit, yeah, I think they want you to include this limit comparison test 1 over x squared minus 1 also converges. You see, right? So I'm gonna do the same thing here. I'm gonna say since 1 over x to the 4 converges, and then 1 over x to the 4 plus 1 also converges by limit comparison test. By limit comparison test. You see, right? So this is the case. Let me turn off the